Okay, finally I'm going to talk to you about size reduction. Once again, we build everything from a R&D scale machine to a pilot scale to a production scale. What is size reduction? Well, some people call it milling, some people call it comminuting, and it's typically used in pharmaceutical applications to uniformly size products that are going to be then blended and compressed into tablets or filled into capsules. This shows the fact that our machines are basically a hybrid between a Fitz mill and a co-mill. And are many of you familiar with the what are called the SUPAC regulations for scale-up and post-approval changes? I know it's a U.S. guideline, but it's for the use of equipment that is similar in functions. And our machine, our granumel, which we have at the exhibit, by the way, a small scale one, is actually a screening mill as well as a hammer mill. So if we can show some of the more animation there. Basically what we're doing is we're feeding through a screw feeder. We impact the product, and the product then passes through a screen to discharge. Go ahead to the next one. This is the inside of the machine, and it's got a rotor connected to a variable speed drive, and we make it in various forms. This is a flat edge, which would be used for fine grinding. We also can make it in a rounded configuration, which is more useful for wet milling. And we also make it in a knife-edged version that would be used by some people that are using the knife edge, for instance, with a Fitz mill. So the advantage of this machine is that we can do a variety of tasks with it. We can delump, we can fine grind down to 37 microns, and we can use it for wet milling and the dry milling. It's a very versatile machine, and it can be taken apart, and cleaned in a tub. So you can take these machines apart very quickly. They all come apart with triclovers and components that can actually be put into a sink and cleaned. And there are no cracks and crevices within the machine. And this probably doesn't mean anything to you, but we have what's called the USDA 3A rating, which means that in the United States, these machines can be used for processing milk products, which is the highest sanitation requirement for this type of a machine, which means that it's designed to be able to provide for easy cleaning and very thorough cleaning. Okay, we can provide these machines for both the R&D level, for the pilot scale. We can make them inline, or we can make them standalone. So sometimes we'll put a milling machine directly beneath the high shear mixer on a swing arm. So you can move the arm back and forth when you need it or you don't need it. Put it underneath the discharge, wet mill the product, vacuum it, or gravity feed it into the fluid bed. You can do that, or you have a standalone machine which can be pushed around and used for a variety of applications. And that's our pilot scale and manufacturing scale fluid bed. That's got a hopper, got a screw feeder. This is the operating chamber right here. Oops, back up. This is the operating chamber, and then your discharge. We can make these dust-free, by the way, through various options that we offer. Okay, we also do controls. Batch architect controls are basically Allen Bradley hardware with our own software. We have our own software developers, and we work with you in developing the software for the application that you have. We write the software, we send it to you, we send our technicians down, or very soon we will have a technician right here in Sao Paulo capable of being able to troubleshoot and help with your process controls. And our system is called Batch Architect Controls. And if I would encourage you, I've gone kind of fast over an awful lot of territory here, to go to our web page. We have a web page, www.fluidairinc.com, and it'll provide a lot of detail on some of the things that I've discussed with you here. Okay, I'm wrapping up here, and I think I'm within my time limit, right? This shows an application where we're high shear mixing And this has the mill beneath the mixing bowl. And what we're doing is we're vacuum transferring it to the fluid bed using the fan on the fluid bed for the transfer. And this is a bowl inverter. This picks that bowl up, inverts it over a dry mill or over screening, however you're going to process your product next. This is one execution. We do work with our customers in designing the facility. In this case, we're using the mixer located here on the floor, but we can also produce a stacked version where we put the high-shear mixer, elevate it, and then discharge by gravity into the fluid bed. So there are a variety of different applications and uses, and it's all dependent on our customer and what their experience is going to be in processing products as to what we recommend that they do, because we want to give them the most efficient system for their product mix in the space that they have available to install the equipment. Okay, thank you very much. I appreciate it. If there are questions, please, I'll be happy to try to field them.